Hi, this is Mrs. Kalinicki, and we're reviewing for your Unit 3 test on expressions, factoring. Here are some examples of some things that will be on your test. You need to know what an algebraic expression is. Expression is something using letters, aka variables, and constants, plus your basic operations, adding and subtracting. You need to know what equivalent expressions are. Well, if I distribute, my expression is the same as the expression I started with, so those are equivalent. Like terms and the word linear, as well as our properties, the commutative property, the associative property, the multiplicative and additive inverses, the multiplicative and additive identity, and I'm actually going to add another one, which is the distributive property. All of these properties will be on your test. Topics: evaluating expressions using PEMDAS, translating words into expressions, and combining like terms. Alright, so let's get started. Some basic keywords when I'm translating: adding, like the word sum, or added to, or total. Subtracting is like the word difference, less than, or subtracted from. Some additional words that you may want to add is if I want to say how many more, or how many less, or if I'm doing any kind of comparing. Ooh, hello. Little error there. Comparing. Okay. So again, subtracting involves difference, less than. I can even do how many more, how many less, or anytime I'm comparing. Multiplication is product times double, which means 2 times, and per. Per can also be used for division, but I also have the words quotient, divided by, split, and half. And I want you to circle or underline, this is when we're doing simplifying, circle or underline key terms to combine them. And remember your integer rule, same signs add, different signs subtract. Okay, so the first example problem over here is subtract 8 from 5 times a number. So we know I'm subtracting, and I know I'm multiplying, because times is a multiplying word, and subtract is subtraction. Except this is key, the word from. If I subtract from something, it's like taking something from someone else. The someone else has to go first. So I'm going to start with the 5 times a number. 5 times a number, well, that's any number. I'm going to use x here. You can use n or any letter you'd like. Then I'm going to subtract 8 from 5x, which is where I do my subtraction sign and put the 8. Now, because subtraction is not commutative, I cannot write 8 minus 5x. Those are not the same. So 5x minus 8. Now I have to simplify. Simplifying by combining like terms. What's a like? 5x is a like with positive 3x because they have the same variable and the same exponent. 5x plus 3x gets me 8x. Same signs add and keep. Other terms that are alike, my positive 9 and my negative 6. These are different signs, so I have to subtract them. When I subtract them, I get 3. Final answer will be a positive 3. 8x plus 3. Now when I'm subtracting, it's a little different. I'm going to use my rule of leave, change, inverse. Anytime I'm subtracting, it's the same thing as adding the inverse. 6x plus 2. Change it to an adding sign. And inverse, that 5x becomes negative 5x. And that plus 1 becomes minus 1. And now I'm going to do the like terms again. 6x minus 5x gets me 1x. Ooh, you can't see that, sorry. There we go. And positive 2 and a negative 1. Different signs subtract. I get 1, and it is going to be a positive 1. Final answer, 1x plus 1. Alright, keep it going. Some additional problems. A rectangle has side lengths x plus 12 and 4x minus 2. Write an expression that represents the perimeter of the rectangle. Express your answer in simplest form. Alright, if it's a rectangle, I should probably draw one. And label. X plus 12 on this side, and 4x minus 2 on this side. And I want to do the perimeter. Perimeter means add all of the sides. So I'm going to have to write a pretty big adding problem here. X plus 12 plus 4x minus 2. Another x plus 12. And another 4x minus 2. Whew. It's a really long problem. Now it says express your answer in simplest form. That means I'm going to have to combine like terms. These are all like terms. I'm going to put a 1 in front as a coefficient to help me remember. 1 plus 4 plus 1 plus 4. That's 5, 6, 7, 8, 9, 10. 10 x's. Ooh, it's a lot of x's. Positive 12 minus 2. Another positive 12. Another minus 2. That makes positive 20. Final answer on this part is 10x plus 20. Part B says factor my answer. Okay, when we did factoring, we wrote out both terms separately. And we wrote what multiplies to get these terms. Always start with the smaller number first. 10. Well, I can pick 10 times 1. I could pick 5 times 2. But I want to pick the largest number I possibly can. The largest number that also goes into 20 is 10. So I'm going to express 10x as 10 times 1 times x. 20 can also be represented as a product of 10. 10 times 2. Now I'm going to do is I'm going to circle what they have in common. And right when I get to this point, the expression is super easy to write. I write the 10 out front, parentheses, like a distributing problem. I write my 1x, which is left over from the first term, and my 2, which is left over from the second term. My original problem had an adding sign, so my final problem will also have an adding sign. And this is my final factored answer. To check that it's right, all you do is you would check with using the distributive property. 10 times 1x, that's 10x. 10 times 2, that's 20. So I'm all set. Next one, identify the terms. Well, each operation is going to separate your terms. Adding is going to separate the terms, subtracting is going to separate the terms. So I have 3 terms. I have negative 5x, I have positive 2yz, and I have negative 8. Again, my handwriting's not the best on this, so I'm not going to write these on the line. Identify the coefficients. The word co, like co-worker, someone who helps someone else. The coefficient are the numbers in front of any variable that you see. So in front of this variable, there's an 8. In front of this variable, I don't see a number, but there's actually, if I had to write one, a 1 there. And it is going to be actually a negative 1. And then in front of this a, in front of that variable, is a negative 8. So my 3 coefficients are 8, negative 1, and negative 8. Now the constants. Constants are always that represent the same number. Well, anything with a variable next to it can vary depending on what that variable is. So the only numbers that will remain constant are the numbers that are all by themselves, like negative 5, like negative 53. Those will never change. Their answer remains constant. Okay, moving on. Simplifying, again, more practice. Simplifying using LCI, adding the inverse. 12 minus 4x plus negative 14 minus 8x. Combining like terms, negative 2. Negative 12x. Final answer, negative 2 minus 12x. Again, you can rewrite it slightly. Another answer that would also be correct is negative 12x minus 2. These guys are all like terms, so I can add all of their coefficients together. Negative 16 plus 8 is negative 8. Negative 8 plus 9 is actually a positive 1x, or just x. To join a gym, Amber must pay $75 enrollment fee and $32 per month. Write an algebraic expression to represent the total cost of m months at the gym, including the enrollment fee. Okay, so I walk in the gym, I automatically have to pay $75 for an enrollment fee. And, plus, I also have to pay $32 per month. Now, the fact that the word month and the word per month is here means I have to multiply $32 for each month, which is why the letter M that they told me to use is going to go next to the 32. I can't do anything else with this. This is an expression in simplest form. All right, final questions at the bottom. Name the property. Because there are 3 terms here and they are in the same order, that's the associative property. They are associating with different numbers each time. This one, 1 times 245 is 245. Well, the number didn't change. All I did was multiply it by 1. That is the multiplicative identity. 3/4 times 4/3 equals 1. Well, 3/4 and 4/3 are reciprocals of each other, also known as multiplicative inverses. And this one, a plus 0 is a. Again, a stays the same. That's an identity. And because I'm adding, that's the additive identity. Okay? Moving on to factoring. In order to do factoring, you have to know the distributive property and factoring, know how to factor expressions, and find the GCF. We had already done one example, but here's a couple more if you need more practice. You can use prime factorization to break down terms into their prime factors and then circle their common terms. Instead of prime factors, I usually just break them down into their typical factors. 12, I can write 12 times 1, I can write 6 times 2, I can write 3 times 4. The question is, which one of these, the largest one, can possibly divide evenly into 18? Well, 12 can't go into 18, so that's the biggest factor. The next biggest factor is 6, and that does go into 18. So I'm going to write 12x as 6 times 2 times x. And I'm going to write 18, using that 6 again, as 6 times 3. I want them to have something in common. Here's where I circle the like terms, and now I'm going to write my finished expression as a distributing problem. 6 goes outside of a set of parentheses. What's left over on the left side will be 3. What's left over on the right side is 2x. And my final answer will have the same operation as my original problem. 6 times 3 plus 2x. Factoring is the opposite of distributing. So by checking 6 times 3, that's 18. 6 times 2, that's 12x. I'm going to do some distributing here. 5 times x, 5 times 2. Distribute means give out, and we're giving out using multiplication. 5 times x is 5x. 5 times a positive 2 is a positive 10, and I'm done. Here are some additional factoring and distributing questions. Again, I like to write the 2 terms out separately. Factors of 9. 9 times 1, 3 times 3. 9 actually works here because 9 does go into 27. Going to circle what they have in common. My final answer will have 9 outside of a set of parentheses, 3x on one side and 1 on the other side with my addition sign. Done. Next one. 10x. Ooh, handwriting's getting really bad on this. And 25. I can write 10x as 10 times 1, but 10 will not go evenly into 25, so I have to pick 5 and 2. Using one of the same terms that they're going to have in common, my final answer will be written as 5 times 2x plus 5. And the last one is just a big distributing problem. I'm just going to distribute. 5 times x squared, 5 times a negative 2x, and 5 times a positive 1. And there you have it. And finally, I think we're on the last page. Oh, no, we have a couple more. Find the GCF of this pair. All right. Again, you can break down each of these by their factors. 18 is 1 times 18, or 2 times 9, or 3 times 6. 66, 1 times 66, 2 times 33. Does 3 go in? Yeah, 22. Oh, I'm gonna run out of room. 4 doesn't go in evenly. 5 doesn't go in evenly. 6 goes in evenly 11 times. Is it gonna fit? Oh, it's so tight. I think it'll fit. All right. The greatest common factor, the greatest number they both have in common, they both have 6s. So the GCF here is 6. What is the GCF of 45x squared y and 9x cubed? Well, I'm going to start with the largest number they have here, and that's 9. 9 does go into both of these, so 3 is not going to be it. Now, based on the variables, I have to look and see what can I borrow from each of these. I can borrow a maximum of the smallest exponent that I have. This is an